Okay, what we have is got a layout here of what we're going to do on this project. It lays out all the lights, lays out all the plugs, and lays out the switching. We even have a little color graphics for you, so this will make it kind of fun. Oh, by the way, I'm Professor Scher. I'm here to show you how to do it. Basically, all of our wires going back to the electrical panel are going to come up through our point of entry right here. For your homeowner, pretty much you're going to want to stub your wires down into your basement, down into your crawl space, or outside to the outside of your building for a certified electrician to hook up at a later date. If you are an electrician and you feel comfortable doing that, then you can go ahead and run these back to your main panel. So starting out from here, we're going to have a general circuit for lighting. That's going to be your red circuit here. It is also going to run your convenience outlets. This particular circuit is going to be on the arc fault circuit interrupter. Remember, that's your real sensitive circuit breaker, designed to protect the electrical system, the electrical lighting, to a very high level in the bedroom for fire reasons. In other words, if you have a little thin extension cord and it's running underneath the wheels of your bed or something and it gets crushed, this could get hot and catch fire long before a regular circuit breaker ever shuts off. This arc fault circuit interrupter will shut off immediately. As a matter of fact, if you plug an old clock into it, or an old device of some sort, an old cell phone charger, that arc fault breaker is going to just keep shutting off and you're going to wonder why, and it's just there to protect you. An arc fault circuit interrupter it's a circuit breaker on steroids, basically. It's just a circuit breaker, goes in the circuit breaker box, and it monitors the neutral as well as the hot. So a regular circuit breaker just tells you if you're drawing too much current on the hot leg. An arc fault circuit interrupter is going to measure the amount of electricity going through the neutral and going through the hot wire. It's just kind of like a water wheel. If you dump a gallon of water on a water wheel, a gallon of water is going to come off the water wheel. It's the same thing when you're running a light or any type of appliance or anything. You're pushing electricity through to drive this device, and through the neutral is coming back the electricity going to ground. So an arc fault circuit interrupter basically is measuring the power going in and measuring the power going out. And if there's a deviation, if any electricity strays anywhere, it's going to shut off. Arc fault circuit interrupters is a circuit breaker. Those go into the circuit breaker panels. You're probably going to want to leave that for a certified electrician to take care of. So, if you're a homeowner and you're not a licensed electrician, you're not a certified electrician, definitely hire someone to come and put that circuit breaker in for you to control your system. Now, for your media circuit, this actually is also in the bedroom. Anything in the bedroom does need to be on an arc fault circuit interrupter. So we are going to put an arc fault breaker on that also. It's going to be what's called a home run all the way back to the circuit breaker panel, so that nothing interrupts or interferes with our media center. Our television is going to be over here, and our DVD, sound system, and etc. is going to be over here. The fireplace is a dedicated appliance circuit. It's not going to require the arc fault circuit interrupter, but you may want to check the codes in your area. You may want to talk to the inspector in your area because he could require it. So we've got our three circuits. We've got our red circuit, we've got our blue circuit, we've got our green circuit. Those are going to be home runs back to the circuit breaker panel. We've got something else here. We've got a purple line. That's going to be our four-way switch. It's going to start out with a three-way switch to a four-way switch to a three-way switch. Let's see if we can get a little better understanding of that, and also tell you what we're actually going to be doing with this. We've got landscape lighting out here, and we want to be able to control it from multiple areas in the building. We're going to control it from about 3 areas. Now, your standard three-way switch, even though it says three-way, really only will control in 2 locations. Basically, a three-way switch will turn on in one location. You can turn it off in the other location, or you can turn it otherwise at the second location. So you have 3 possibilities: on here, off there, and then you can reverse it by turning it on again. So they call that three-way. In order to do not two-way. You would think it would be a two-way. It's not, it's three-way. In order to do a four-way system, basically what you're doing is you're just adding another switch in between. It gives you more options. And you can add as many four-way switches as you want, up to about 10 or so. I've got a little drawing over here that shows you pretty much how it works. The hot goes into the three-way switch. The traveler legs go out of the three-way switch to the second three-way switch. And the hot comes out of the three-way switch going to your light. Your light, of course, is going to have your neutral, and coming off your switch is going to be hot. That's also the direction and travel of your electricity, as I was saying, kind of like a water wheel. This would actually be going to, essentially, to ground at some point. To add a four-way switch is pretty simple. Basically, what you're going to do is you're just going to break your traveler legs, and you're going to insert a four-way switch. If for some reason you needed to add another four-way switch, pretty simple. Going to add another four-way switch. In this case, I believe we're just going to have two three-way switches and one four-way switch. We're going to start out over here in the adjoining building with a three-way switch. We're going to come over to our building that we're working in with our four-way switch, and we're going to continue to the lower part of our project. There's actually another area to be remodeled or finished off at a later date, which is going to be the men's room. I guess it could be the women's room, people's room. That'd be the guy's room. Okay, well, we got the message there. So we're going to have our three-way switch downstairs. What this is going to control, ultimately, is we're going to control our landscape lighting all around our project. We're going to probably have some uplighting for our trees. We're going to have just various landscape lighting all the way around. That's going to plug into a transformer that we're going to have located somewhere in our basement down there. And transformers, low voltage lighting, number of watts required for that, that's going to have to be a different segment. So we've pretty much covered our lighting, our receptacles, our media center, power for our fireplace, and our four-way system for our low volt lighting. We're going to move on now to installing our recessed lights and to installing the circuit for the media center and the fireplace. All right, so now we're going to do a demonstration. We're going to show you how we detail or how we wire and install these fixtures. Basically, we've got a couple of different things, a lot of different options with these fixtures. There's a lot of information that we're going to be covering. It's going to be a little bit fast, but we'll try and cover it in detail so that you'll understand exactly what's going on. All right, so we're going to be working on the installation of these recessed cans. There's quite a few variations on the cans. So you're going to want to talk to your home improvement center, whoever's supplying your cans for you, to make sure that they give you a can that's appropriate for your particular installation. In this case, we're using just a standard IC-rated recessed can. This is a 6-inch can, referred to as a 6-inch can, that has to do with the diameter of the opening here. Got a lot of variations. Again, check with your home improvement center, wherever you're getting your supply from, and make sure that they help you choose out the can that's going to be right for your particular installation. Now that we're ready to get started on the installation itself, you're going to need to locate your fixtures. You're going to make sure you have enough light in your area. You're going to make sure you don't have too much light. You're going to get them centered and lined up with the areas that you want your light to be in. Just a quickie way to do it is to make it even, make things symmetrical. You pretty much can't lose if you make things symmetrical, but if you have special places that you want lighted, then you're going to want to locate those lights in that area. So if you're using trusses, your trusses can be spaced anywhere from about 16 inches to 22 inches apart. We've got extension arms that can spread out for whatever dimension that you happen to need. You can adjust your cans within this area from one side to the other side in order to get your location correct for your can. Once you've determined exactly where you want your cans, you're going to go ahead and put them up. You're going to put them in between the joists, and you're going to go ahead and drive your nails in. Some areas may require that you screw them as well as nail them, but the nails are required and are accepted in most areas. Once you have your can located from side to side in this way, they also make a little device that locks the unit in so it doesn't slide around anymore once you get it into the proper location. So you're definitely going to want to lock them down once you get them in their proper location. Of course, you're going to need to mount both sides. You've got 4 locators. You've got 4 nails you're going to have to drive. Once you have it all located up in your ceiling, then you're going to be able to move on to the actual detailing or the electrical wiring. There's an access box right here. There's an access box right here which will allow you to get to the inside of the fixture. Pop the cover off. We've got a couple of different ways that we can actually run our wires in. This particular connector is designed for 1 Romex, and that can just be inserted right into the connector as so. That's just an example there. If you're using a commercial installation, then you may want to use this for a different type of conduit or a different type of connector. In this particular application, we're just going to be using the Romex style. So I'm going to go ahead, I'm going to make a little demonstration of how this detailing or how the wiring actually takes place. Okay, so now we're going to go ahead and move on to the wiring and the detailing of this fixture. There's going to be little differences in the way it's done because the wires will actually be stapled in place up above. As it is right now, I'm just going to take this one piece of wire, cut it into 2 pieces like we're making a junction going from one recessed can to the next. I'm going to go ahead and install these. In their appropriate position. So one of them is going to be right about here. The other one's going to be like so. Of course, again, these are going to be stapled into their proper positions, and they'll actually be held a little bit differently. So the first thing we're going to have to do is we're going to have to strip our Romex down. There's a multitude of ways to do this. They have some tools that will strip the Romex real carefully. I use a utility knife. I try not to have it too sharp because I don't really want to nick the wires. You've got to be pretty careful not to cut the black or the white wire while you're doing it. In this particular case here, I'm probably going to actually have to pull the wire out. I don't think I can do it in the box. We'll give it a try though. Okay. So we're just going to go ahead and strip this wire. I'm going right down the center of the wire so that I don't hit the conductors in any way. I'm removing the paper wrap off the ground wire. Do the same thing on the other one. As I was saying, they do make some tools for stripping. Basically, it's a little clamp-on device. It has a little knife in it. I don't like those personally, but they would probably be a wise thing to use for a homeowner. If you're a contractor, you can make your own decisions in terms of what you want to use. Okay, so I'm going to reinstall the wires. Now here's a couple of things that we really have to look at. This particular can is all metal, and one of the very important things is that it's properly grounded. As you can see, the ground wire is actually connected to the can. I'll give you a real view so you can really see that. You want to make sure that that ground wire is actually connected to the can, and we're going to connect that to our ground wires, which are going to be hooked to the ground system of your main electrical system. It's very important that there's no stray electricity that winds up in these metal parts in case they are touched accidentally while you're changing a light bulb. I mean, from down below, you could actually touch this can. There could be stray electricity in it. We've got to make sure to prevent that by having grounding. So now we're going to go ahead and start with our what's called detailing, which just means wiring. We've got a couple important things that need to be dealt with. We've got various size wire nuts that handle various numbers of conductors. And when you buy your wire nuts, you're going to need to speak with the person at your supply house, your home improvement center, and make sure that they give you the right wire nut for the right number of wires that you're going to use. There's actually, on most boxes of wire nuts, it actually has a diagram or a description of how many wires are used in a particular wire nut. So again, you're going to need to get that information from your home improvement or your supply house personnel. We're going to start out with our grounding. There are many different ways to connect your ground wires. You could use a grounding grommet, crimp sleeve. We're just going to go ahead and use wire nuts in this particular case. So we're going to bring our ground wires all together into one location. I like to try and fold my wires into my box in a way that I feel they're going to lay nicely. I've brought all my ground wires together. I'm going to go ahead and cut them off so that they're even. And I'm going to use what I've determined to be the appropriate wire nut for this particular application. So we're working on installing wire nuts. We're talking about getting, whether you twist the wire or not. Again, it's just a personal preference. If you ever have to go back and troubleshoot anything, when they're all twisted together, I find it a real pain in the butt. My guys, I tell them, don't twist the wires. When you put your wire nuts on, it tends to twist the wires anyway. So if you get your wire nuts pretty tight, it will hold it. What I do when I'm done wire nutting something, I pull on the wires and check and see, are the wires actually fastened in the wire nut? Because again, like I said, there's little, the inside the wire nut's got a coil. It'd be nice if we had a little breakdown for you. Maybe we'll get tech to put a breakdown for you on the wire nut. It actually cuts into the wires. There is a little difference here. We have a stranded wire, which is the wire from the fixture wire, referred to as fixture wire, and we have the solid wire. And when you're attaching these two different wires together, you do need a wire nut that's rated for stranded and for solid. And sometimes getting the stranded to hold with the solid really is an issue that you got to deal with. You really have to worry about it. So I give a little tug on the wires, make sure they're well connected, make sure the wire nut's on all the way, good and tight. This particular brand of wire nut actually has a torque setting, believe it or not. When you turn this wire nut past a certain point, it just starts slipping because they don't want you to over torque the wire. So now we're going to go ahead and we're going to do the power wires. We'll do the neutral next. So again, the same situation. I've got a stranded fixture wire. I'm going to twist the stranded wire together, make it nice and tight. I don't want all those strands breaking off. When you're putting it together with a solid, you're going to want it to be as solid as possible. The strands will actually wind up inside the wire nut and won't make a very good connection. So it is important to go ahead and twist that wire as tight as possible. So I'm going to go ahead and line up my neutral wires. I'm going to fold the neutral wire from the far side so that it'll lay down in my box nicely. I'm going to gauge the length of my wires. I'll give them a cut. Strip off. I'm going to strip them off approximately 5/8, 3/4 of an inch. In this particular case, I'm using a stripper that actually has different size holes for different size wire. The largest hole is for a 10 gauge, the next one is for 12, 14, 16, and 18. In this particular case, we're using 14 gauge wire, primarily in a residence, for lighting, convenience outlets. You're going to be using 14 gauge. The smaller the number, the bigger the wire in this particular case. So now we've got our wires ready to be connected. I'm going to be very careful and make sure that I'm holding this stranded fixture wire even with the other solid wire so that I get a good connection with my wire nut. Again, I've already determined what size wire nut that I need for this particular application. It is rated for stranded wire, and it's rated for the proper number of wires that we're going to use. As you can see, I'm not twisting my wires, but if you wanted to, you could twist the solids together and then hold the stranded next to it. So I'm going to go ahead and put my wire nut on. And I can feel it coming to its torque stop. I'm going to check, make sure that my wires are connected solidly. Whoa, look at that. That fixture wire popped right out. Even a pro can make that mistake. That's why I check, because later on, this fixture isn't going to work, and we're going to wind up having to disassemble this fixture in order to get to the reverse side opening, which I'll show you when I'm done detailing. So I'm going to go ahead, pull my torque nut off, my wire nut off. I'm going to...
Could this be an instance where you would tape them together?
You could do, as a homeowner, you could do anything you want. As an electrician, you wouldn't do that. What I'm going to do now to ensure that the fixture wire gets a good bite is I'm going to go ahead and I'm going to extend the fixture wire a little bit past the solid wires. I've found that different brands of wire nuts like to have the fixture wire a little bit past the solid wires. I've even found some that the stranded wire needs to be a little bit behind the solid wire. But I'm going to give this a try. We'll see how this goes. Okay, it is torqued down. We'll give it a try, check it again. Fixture wire is well attached. We'll try the feed, and we'll try the load, and those are attached well. We'll go ahead and move on now to the hot wires. So again, I bring my hot wires to a good location inside the can. I don't want the wires stretched out. I don't want them really short. I need them to be long enough so that I can fold them down into the can easily and there's no stress on them. I've got the fixture wire. Again, it's real critical. Straighten out all the wires on the fixture wire. Twist them together really solid. You've already seen that we did have an incident with the wire not connecting properly. Cut them off. Strip them with the proper gauge, about 3/4 of an inch. Got my selected wire nut. I'm going to go ahead and put the fixture wire a little bit ahead of the solid wire. I feel it torque down, check my fixture wire, check my load, check my line. By the way, load is going to the next light, line is coming from the previous light. Line is referred to as the power source from your utility company. So coming from the line side, going to the load side, which would be a light or the next fixture. So we've got our ground, We've got our neutral, and we've got our hot wires all connected now. We're going to fold them gently into our box. As you can see, they're laying down there neatly, wires in position. We've got our cover. Go ahead and install the cover. And that's a basic detail on that fixture. Now, I did tell you that if there was a problem with this, once this was sheetrocked in place, there is a door on the other side exactly like this one that can be removed. And in order to do that, you're actually going to have to take out the cylinder. There's a couple of screws on the inside of the can. I believe there's 3 of them actually. There's one right there. There's one right up here, and there's another one up on the top here. If you take those out, the cylinder will slide out, and you'll be able to reach your hand up inside and remove this door right here, which will let you get into the back of the fixture if you have to do some wiring after the sheetrock's installed, or if you can't get into the attic. Then, of course, you're going to have to put the cylinder back in and reattach it to the frame of the unit. So there we have the detailing or the wiring of the fixture, where we're going from one fixture to the next fixture. If this was the last fixture on the line, there would only be one wire, just the one going into it. Now we're going to go ahead and start locating our fixtures and installing the fixtures. All right, so now we're going to go ahead and start laying out our lighting. Before we nail them up, we kind of got to figure out where we want them exactly. Now the homeowner has given me an idea where they want their fixtures. I'm going to modify it just a little bit so that I can get the light spread the way I want it. Pretty much, they want the lights here, 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 and here. What you want to do is you kind of want to make sure that your light spread, you've got your light up here, you've got a couple of them, and they're going to spread the light down this way. And we want to make sure that there's a decent overlap. We want to make sure that there's a decent overlap on our fixtures, on our fixture light. So you can see we've got a little bit of overlap. These kind of things you're really going to have to talk to your home improvement supply and make sure that the fixture is rated for this, what the spread is of the light, what light bulbs you're going to use, but this is a good generic way to understand that you're going to have a little bit of overlap with your light fixtures. What I did here was basically I made it so that the distance from here and here were the same, and I tried to actually make this distance the same. My drawing is not indicating that it's the same, but this dimension is about 54 inches on all of these dimensions. And what this is going to do, the way it's going to leave the light fixtures, is that the spacing between these two lights is going to be about 102 inches, which is a little bit less than double the distance away from the wall. So our spread is going to be pretty good in terms of right here. We're going to have a little bit of overlap. We're going to have a good even light casting around. And we're going to be a little bit tight here. This is only going to be about 78 inches. But it's a good compromise. You're going to have a little bit stronger lighting in this center area right here. Our fixtures are more or less going to line up with the edge of our windows. They're going to be about 54 inches off on each side. It's going to leave us some room in case we want to add any other low voltage lighting for any particular pictures or any particular things that we may want over our bed. Other things to think about.
Home Improvement Camp. Have at it.